think we're live now. If you can hear us properly, tell us.
Okay, let's see if I hit. Okay, to make it slow.
Yeah, we're 15 seconds in. Okay. Good evening, everyone.
Hello.
Good evening.
Let us know if you can hear us, all three of us, properly. We're gonna start shortly. We're just trying to get something to begin with. Are you still in the hand over there?
Nothing's happening. Let's see.
The physical one?
Yeah.
I'm going to go ahead and ask this on the chat.
There it moves, yeah. Okay, that's a bright star, isn't it?
Take that. Got it.
Okay. Okay, good.
Yeah, our connection's excellent, so I don't think that's a problem. No buffering. Yeah, let us know in the chat that you're here.
Huh?
So we can let us know. I'm talking to the audience.
Okay.
Let us know in the chat if you can hear us.
Okay, it's
so far maybe not.
Yeah, the chat's pretty quiet. Okay, I think we got confirmation. So maybe we'll just wait for a few more people to join.
Okay, what we're doing right now is we're calibrating the auto guiding, which enables the mount and the telescope to accurately stay on a target so that our longer exposures won't be blurry. This is always important in doing astro imaging. Anyway, just want to say good evening to everybody. Thank you for joining with us. I'm Doug Solisey, that's Vivek Vijay Kumar, and Professor Scott Cardell from Palomar College and from the Palomar College Observatory. We'll be looking at galaxies tonight, a lot of different kinds of galaxies, interacting galaxies. And also we're going to talk about light pollution, and I can give you a glimpse of what kind of equipment we're using too. Let's see here if I can find the right, oops, what happened to my images?
Your screen sharing thing is, you just need to close that.
Oh, okay, well, if I click on this, won't it pop up?
What?
Oh, close the screen sharing, okay.
Yeah, you're already doing that with us.
Okay. I don't have my minimized pictures anymore.
No, they're there. It's the blue mountain stuff.
Oh, the blue mountain. Okay, here we go. Okay, all right, here we go. Yeah, this is the equipment we're using tonight. This is, whoops, what happened? Yeah, this is an 8-inch Ritchie Quitian telescope. It basically.
I am. Can you hear me? And I think we're back. Right. Hey, so Jerry's still with us. That's good to know. Yeah. All right. Right. So tonight we're looking pretty much exclusively at galaxies, and galaxies are pretty awesome things, if you ask me. The most people that would be listening probably know that we live in a galaxy, the Milky Way, and we're going to be looking at other galaxies. One of the cool things about spring is we're positioned so that we can look out of the plane of the galaxy. You know, in winter and in summer, we're really looking into the heart of the galaxy for what we see in the evening part of the sky. But in spring here, we're looking out of the plane of the Milky Way. And we have a front row seat at a lot of galaxies, especially in the constellation of Leo and Virgo, and we'll be looking at a bunch of these tonight. So for anyone that doesn't know, galaxies are like cities of stars in some ways. And everything that's going on in the life of a human, you might imagine, is happening in a big city. And within a galaxy, the same is true, but for stars. And there are stars being born, and there are stars that are dying, and there are stars that are going about their daily lives. And so galaxies are these vast collections of stars and gas and dust. And we're going to be looking at a group of them off in Leo, which are some pretty awesome ones. M66 and M65, Charles Messier discovered these objects back in 1780 as part of his catalog of things that aren't comets. And these are conveniently close to each other in kind of the hindquarters of Leo. All right. M66 and M65. Okay, then I'll just talk to myself. Great. But that's okay, because everything's giving us an issue tonight. So let's ideally, we're going to be looking about 35 million light years out, and we just had a glimpse of, I think. Actually, that's it. M66, isn't it? Yeah. Doesn't look quite like it. Sure. So we're looking out about 35 million light years away. M66 and M65, they're actually neighbors of each other in space, not just both the same direction. And some of the galaxies we hope to see tonight are actual real neighbors of each other, and others are just sort of both that away in the same direction of the sky, not necessarily neighbors. But M66 and M65 are neighbors of each other, along with another one that's sometimes called the Hamburger Galaxy, NGC 3628, because everything has to have a number. So let's see. We're oh, okay. So we're still. Go ahead. All right. So we're still sticking into the constellation of Leo, but at the sort of the other end of the constellation, there's actually a group of 4 galaxies sort of centered on NGC 3190, which is really not a very sexy name. NGC for the new general catalog, it's just number 3190 in there. This is a this particular galaxy was discovered by William Herschel, the same guy that found the planet Uranus. And Herschel, often with his sister Caroline, would find things literally by pointing his telescope at one place in the sky and then letting the Earth rotate. And as things went past his field of view, he would call them out to his sister Caroline, who would write them down and record them, and it was a great way to find things that way. And NGC 3190 is it's around 110 million light years. Oh no, wait, I'm sorry. It's about 79 million light years away. So it's definitely further than what we just saw before, which was about 35. We still on our way there? Okay, great. Just checking. So this is we'll be seeing it's a spiral galaxy, and I think we'll get these others in the field of view, which includes another spiral, another one that I would say is kind of a distorted spiral, and an elliptical galaxy too. Right. Right. So all of that fuzz, go ahead. Yeah. Yeah. All of that fuzziness that's there is actually the light of stars and maybe some glowing gas clouds within these galaxies. They're too far away for us to resolve those as individual stars, but all that fuzz that surrounds the bright core of the galaxy, where we have tremendously more stars. Now we have a bit more of the galaxies to see there. Yes, you can see it right there. And so the other one that's just out to the right is the elliptical up near the bright star there. And it turns out that one's not actually a neighbor of these other three galaxies. These other three galaxies are together in space at about 79 million light years. And that big elliptical galaxy is actually 110 million light years out. So it's definitely farther away. Right. Are you going to 2903? Oh, okay. Okay, that was actually pretty near where we were a little while ago. All right, so yeah, this is, go ahead. All right, this is actually a really cool galaxy. It goes by the name of NGC 3628. It's a neighbor of M66 that we saw earlier, and N65, which was just out of the field of view, what we're looking at. But it's a nice edge-on spiral galaxy with a big prominent dust lane in there, about 35 million light years from us. And yeah, it's a really nice target. A wide field telescope will actually show this and M65 and M66 all at the same time. I know with my 10-inch Dobsonian, I can see all three of those galaxies at the same time. No, maybe that's, well, let's see. Discover what we're pointing at. Oh, so is it doing the auto sequence? Yeah, you sure can. Oh, so Vivek, it sounds like in the chat, they're only hearing me. Did you catch that? Can everybody hear Vivek now? It says you're Yeah. Okay, so apparently, yeah, everyone's only hearing me, but here is the really beautiful Hamburger Galaxy NGC 3628 with a just really prominent dust lane through the middle of the galaxy. So what we're seeing is just a vast amount of stars, but there are dark clouds of gas and dust that are blocking the light of the stars there. Spiral galaxies typically have a lot of gas in them, a lot of dust in them, that's used to generate new stars. And seeing this galaxy edge on, we get a really nice view of the dust that's within the disk of the galaxy. You can also see that it's sort of especially fuzzy towards the ends. If you go and follow the dark dust lane up or down, that shows that some of the stars of the galaxy are no longer confined to the plane of the galaxy. It's probably because this galaxy has had a close encounter with its two neighbors in space, M65 and M66. And the gravity of those other galaxies has distorted this galaxy somewhat. But it's really a spectacular galaxy, that's for sure. In the hindquarters of Leo. Can you guys hear Vivek now? I don't know. Sure. It's another one of these galaxies discovered by William Herschel. Hey, excellent. Oh, wait. Jerry says yes, Fred says negative. And Jerry says no, he can't hear you. All right. Okay, so yeah. Sorry about that, folks. It's just a challenging evening. Are we sticking on the hamburger, Vivek? We're going to move on. Oh, okay. Okay, so we're going to get a lot. That's okay. I'm catching that on the YouTube feed. So we're going to get a longer exposure here of the Hamburger Galaxy, and before we move on to the next target. And there we go. So just a moment here. Hopefully we won't be drifting too much or having too much vibration from wind. All right, too much shaking around from the wind, huh? Okay, so we're actually moving to the next target, which I think will be NGC 2903. Oh yeah, that's definitely not our best image right there. But if hopefully that's where we're heading. That's another galaxy that's off in the constellation of Leo. Well, I'm glad Jerry's got a good night out at TDS. hopefully it'll stay calm for him. Sometimes in the mountains, things are different than they are elsewhere, that's for sure. Yeah, we had just a bit too much vibration on that issue, but on that image, but you could still see the dust lane in the Hamburger Galaxy. That's for sure.
I think I figured out the problem. My audio should be back now. Can you hear me, Scott?
Maybe. I can hear you. I don't know if anyone else can.
Scott?
Yes. Can you hear me?
Okay, that's weird.
Hey, your audio is back. People can hear you now.
Oh, I figured it out. Okay, let me get this back. Think.
Excellent. So now
So that is
everyone
weird.
can hear us. Let's
Scott,
try to see.
Scott seems to be gone now.
No, I'm
I know
here.
it. Huh?
People
That's
can hear us
weird.
both.
Okay.
Well, we're certainly having tech issues tonight when we have three people in three different locations where we're remotely sort of running the telescope here now. And it's a lot to try to.
No one wants to see that picture of his
Oh, Scott, can you hear me?
Yes, I can.
Wow, that's, okay, that's weird. All right, okay, I think they can hear us both now, and I couldn't hear you for a while. That's why, but let's get this back on let's get this back running. So we're gonna leave behind this blurry hamburger, and we're gonna go to our next target now.
Is that NGC 2903?
Let me see we're going to UGC 5079, so let me pull that up. We're going in sequential order now. Yes, that's NGC 2903. So let's get that going.
So this is much closer than the Hamburger Galaxy. It's another galaxy now, in Leo, great place for looking at galaxies, that's for sure. And Virgo. Getting over there now. This is another spiral galaxy. Another one resembling a virtual.
Okay, I think hopefully they can hear you now. Alright, so we've got the core now, and we've got the dust lanes in the middle. So we're going to get our first 1 minute exposure. Yeah, I think they're starting to have a problem hearing you now.
That's what it looks like.
That is weird. It's never happened.
It's either one or the other.
Let me retry this and see if we can get you back. Okay, I think we're back now. Can you speak up, Scott, so that we can see if you're audible? Yeah, hopefully. Yeah. And oops. Let's go back to the image. Yeah, well, we're having a little bit of trouble with the wind, and yeah, this is Barred Spiral Galaxy, and we've got some. No Scott. Wow. That. This is not our lucky day. Not our lucky. OBS is refusing to add desktop audio. I don't know why. Okay, I think hopefully you're back now. Yeah, I'm messing with this right now to get you back.
We're adjusting our settings.
Can you hear Scott now?
Can anyone hear me now?
Yeah, it's still having problems with that. I don't understand it.
We're seeing broken arms.
I know, everyone's saying OBS because that's what I'm trying to figure out right now. To get you back. Yeah.
Oh, okay, so now I guess they can hear me. Hey, so that's good.
Finally.
Yeah.
Okay, we're done with OBS now? Finally? Great. So
Yeah.
I guess
Yeah.
I'll let you begin with NGC 2903.
Okay, so does this mean everything's actually working now, except for the fact that we don't have Doug? I think so. So yeah, this is NGC 2903. It's a nice barred spiral galaxy in Leo, about 30 million light years away. Turns out our galaxies, our spiral galaxies, come in two varieties. The more familiar, perhaps, to some spiral galaxy and the barred spiral galaxies. As you can hopefully see, there's a bright spot in the middle. That's the nucleus of the galaxy. But there's sort of a bright line that runs kind of through the nucleus, that we can see there. That is the bar portion. Turns out our own Milky Way galaxy is a barred spiral galaxy. And there's some competing ideas as to why galaxies develop the bar and how they maintain the bar. But we don't really know the answer to how that works, which is one of the things that astronomers are still trying to understand. Turned out that discovering that the Milky Way was a barred spiral was also a moderately recent discovery, just I think in the last 20 years or so. I'm just laughing at what Fred read there.
Okay.
Charge, and you have to be 21 to enter. That's right. A barred spiral galaxy.
I think we'll now move on to the. Let's skip. Leo one's too low. I think let's go on to M87, which will be a really interesting one because of this was the galaxy where we had one of the first image taken with radio interferometry on its supermassive black hole. So
right. Generally speaking, our elliptical galaxies aren't always amazingly interesting to see, but M87 is an especially interesting one. So Kevin asked about different theories about barred spiral galaxies. And so first of all, we don't really know if those are permanent structures or temporary structures, the bar that runs through there. Some people think that this is tied to some mechanisms that make the spiral arms in galaxies, which is also something that's not completely understood. There's this idea of what's called a density wave that could be moving through the galaxy that is creating star formation to happen, and that I feel like I'm not going to explain this very well, but the bar might be related to that process, which I think I'm not saying very well, and
Oh, I assure you that's the last Bard spiral for tonight. So
so that if I'm doing a bad job of explaining it, then that's probably okay. So this density wave that's out there, if this idea is correct, relates to star formation, and it's sort of something that perhaps extends out from the center of the galaxy. And yeah, I'm doing a really awful job of explaining this. Gotten tongue-tied here.
Well,
on this.
We've got M87 in our field, and we're taking our first 10-second, so we can, I guess, talk about that now.
Okay, so I'm going to talk about something that I won't sound like an idiot on. So M87 is a giant elliptical galaxy, and giant in every sense of the word. So it's bigger in diameter than the Milky Way is, but the Milky Way is like a flat disk, and this is like a big giant ball of stars. So it is both bigger across, but it's like a big sphere of stars. And it's in the heart of the Virgo cluster of galaxies. Basically, this galaxy is about twice as massive as the Milky Way. And at its core is this supermassive black hole that was famously imaged using the Event Horizon Telescope a couple of years ago. The Event Horizon Telescope was a series of telescopes widely spaced on the Earth that all were imaging the central portion of this galaxy at exactly the same time, pointing at exactly the same place. And they were able to determine, or they were able to collect the first image of a black hole. And the black hole at the center of the galaxy is 6.5 billion times the mass of the sun.
Yeah.
We will not be able to image that black hole with this galaxy. With this telescope.
That being said, there is something we'll see in very shortly that is very interesting. That's kind of related to the supermassive black hole, and that's the relativistic jet, which you can see in M87. And hopefully, I don't know if it'll be too hard for people to see, but if you can see over here, we've got the core of the galaxy. So we're actually we're in a part of the Virgo where we are seeing lots of galaxies strewn across the field. So we've got all these ellipticals. I think these are mostly all ellipticals, but what makes M87 interesting to look at with a high resolution telescope, amateur telescope, is if I don't know if you can really see it, but over here you can see very small little detail. And that's the relativistic jet that comes
just above your cursor. Yeah, right there.
Yeah, right over here we got the relativistic jet, and that's a jet of very, very hot, very ionized gas coming from the direction of the supermassive black hole, which is a pretty, in terms of when we observe galaxies, it's more on the uncommon side, because. So M87 is one of the galaxies where we can see this phenomenon, and it's a very small feature. It's only like 2 to 3 arc seconds in length, but it's pretty interesting to be able to see that trace of something's weird's going on with this galaxy.
Absolutely, and so. It might sound a little bit weird to hear that there's this jet of gas, that's ionized gas that's shooting out from a black hole, because black holes are supposed to be gravitationally very strong and gravitationally attractive, so to speak. And what happens is that around a black hole, typically if it's got material to eat, to suck up, is a really hot disk of gas called an accretion disk. And this is gas that's in orbit around the black hole. And this gas is hot enough that the disk itself glows. That's part of what you could see in the image from the Event Horizon Telescope. But this gas is ionized, it's plasma. And somehow in all of this, intense magnetic fields are produced. And there's gas that's coming towards the black hole that gets caught up in the magnetic field and ejected out at really high velocities, like a sizable fraction of the speed of light.
Yeah, so.
And typically you would get them going out the north magnetic pole and the south magnetic pole. I don't know that we can tell if there is a second jet going the other way from M87, but this is the one that's at least pointed in the direction that we're able to see. And it's pretty impressive.
It's a pretty small feature, but yeah, I think we've got it tonight at least. And I guess in like 30 seconds we'll get our 4-minute exposure, so we'll see how that turns out.
One of the early results from Hubble Space Telescope on M87, before they even did some of the camera upgrades later, was to be able to get spectroscopy on the disk of gas around the core of the galaxy, and could see the tremendous redshift on one side of the disk of gas and a tremendous blue shift on the other side of the disk of gas, because the disk of gas is orbiting rapidly around the black hole. And that was tremendous because you could measure the rate of the orbit of that gas. And knowing the size, the image scale you're looking at allows you to determine the mass of the black hole in the middle. And that was, I would say, one of the really, really solid observations that began to convince people that, yeah, there really are big black holes at the center of these galaxies, these supermassive black holes.
Yeah. Well, our 4-minute exposure came in, and we're seeing, we got a lot of background galaxies around here. And I think we've got our best image of that relativistic jet. Hopefully it's not too bright. That galaxies are just not too bright so that you can make out the relativistic jet. But I think we can go on to our...
Yeah, you can see it. And just on the edge there's another galaxy in the field of view.
Well, I mean, there's a lot of them. There's like...
Oh, I know. But I mean, sometimes these other two galaxies that are close to the same position as M87, like there's those two right there to the right. Sometimes people think that's the jet if they don't have very good resolution in their telescope. They're like, hey, I got it. No, but you got it for sure. Plus these other galaxies too.
We're at 1300 millimeters. I think our image scale is like 0.7, somewhere in that range. So we should be able to, I think, we've got the jet just poking up there, a few pixels wide, but...
Yeah, got it for sure.
Okay, time to move on.
Are we going whale watching now?
Maybe. We gotta look, just doing some shopping. Yeah, we'll just go to the whale. Let's see how that one is. So... All right. Well,
I'm just looking at the list in the order you gave it to me.
Well, yeah. Well, our stuff has definitely changed now. So.
Okay. And answer to Kevin's question, yeah, the jet was above it.
So, one of the most important things for observing is, because we're using an equatorial mount, which we showed you earlier, that requires us to flip when we reach a certain point in the sky. So the way we had planned this thing was to make sure we wouldn't have to do any of those flips so that we could just have a very smooth session. Obviously, we had because of that time delay, some of these objects are now starting to reach that point of the sky near the highest point, the
Oh, right.
meridian. That's what we call it. It's the line from north to south. And if it reaches there, that means it's time for that mountain to flip. So that's a region where you kind of have instability in terms of equipment, because it has to perform a 180-degree turnaround. All right, we got our 10-second exposure, and we got a lot of detail there. So let me just start guiding, because apparently it doesn't want to do that.
Oh, hey.
Okay, no. All right, there's no guide star, but we can... Actually, let me see if we can get that guide star. So one of the problematic things we're having is trying to... Especially when you're using a long focal length telescope, it can be harder to find appropriate guide stars. But I think we can lock on. Okay, no. Well, we'll just use it unguided, but we can see the Whale Galaxy here, so it's irregular, and we should be able to...
There we go.
It in high resolution soon. But yeah, we can notice over here this very faint galaxy. That's a satellite galaxy, and it's very contorted by the gravitational field. Okay, that's
Right. So that's a dwarf elliptical galaxy next to it. Unlike the giant elliptical galaxy that we saw before, the Whale Galaxy, the big one here, is physically in space next to this dwarf elliptical, just like there are little galaxies near the Milky Way too. But I think they're gravitationally interacting, and the Whale is considered a starburst galaxy. Like Messier 82 is a starburst galaxy as well. And those are galaxies that have had tremendous amounts of star formation that have happened, and usually coupled with that, higher amounts of supernovae that occur, and that tends to produce outflow of gas coming out from the galaxy itself, what are sometimes called super winds, of just gas streaming out from it.
you can see a lot of with a lot of detailed dust lanes. We've got some different. We've got the cluster. We got some clusters, and well, generally because of our telescope limitations and how our relative distance from this galaxy, it's unlike other galaxies such as Andromeda or the Triangular Galaxy. We can't really resolve the clusters, but we're able to see the regions where we have more younger stars, or we can see regions that contain nebulae, and those are usually colored red because hydrogen in those nebulae emit are colored red. So we can see all of those little details within the galaxy, but the reason why it's called that Whale Galaxy is because of that contorted shape it has. So hopefully we'll see it better. Okay, we got a little more SNR there, and yeah, we got that satellite galaxy here. So
Oh, there we go. Yeah.
that's our field of view.
Yeah, there's the satellite, and the Whale is splotchy, as you were just describing there.
Yeah.
With these star clusters and with these dark gas clouds and things, and it's not as elegant looking as maybe when we saw the Hamburger in terms of how the dust was arranged, because things have been going on here.
Yeah. Okay, we're gonna take a very quick hop. Just right next to it, there's another galaxy that is, it is gravitationally related, and it's even more contorted than the Whale Galaxy, if you can believe that. So
Is this the hockey stick?
yeah, we're gonna take a very quick hop. Hopefully we might have a guide stars to take the long exposures, but all right, let's head our way there. Yeah. The guiding is very excited to wants to do some work. Okay. So we should be there very shortly. It's a very quick hop.
Yeah, it's in the sky. They're not very far at all.
We're using a very long focal length with a pretty. I don't know if you've already probably noticed by now. This is an atypical camera. It's square, so we got a pretty small field of view. So if we had a bigger sensor or we had a smaller focal length, we would be able to fit both of these galaxies in the field of view. And a lot of good astrophotography shots of this galaxy have both of them in that field of view. But I think we've got it now, so let me just out of hope, let's see if we can get a guide star so we can take some longer exposures. We got one. Oh, that's pretty good.
Great.
So we can take our long, and there we go, 10-second exposure. We're already seeing a very strange shape. It's kind of like a hook, and this is actually called a hockey stick galaxy, and as you can see, it's because it actually is shaped like a crowbar, a hockey stick, but this galaxy is it's even more irregularly shaped than the whale. And with a longer exposure, I think we can make out there's actually a sort of a tidal stream coming out from the right.
Yeah, well, we're not really sure where the puck is.
Yeah.
Sorry, that was an attempted humor. Yeah, but this is clearly not a normal-looking galaxy. That's for sure. Now, according to some sources, this galaxy is actually closer to us a fair amount than the whale. So I don't know if they're. Oh, that looks good.
Yeah.
If they're really related in space or not. But something clearly has happened here. They're
Okay.
You tend not to get galaxies other than really. You tend not to get galaxies that don't look very elegant without there having been a close encounter with one galaxy and another. The gravity between the two will pull and distort their shapes and move their stars around and cause star formation to happen in their gas clouds. So to me, seeing the whale nearby in the sky suggests that they might be related.
They're actually, so I did it. They're actually part of the same group, so they had it.
Oh, okay.
Interaction. So there was the interaction between the whale galaxy and that little, I think Fred called it a fin, and that little satellite galaxy, and that's also, and the hockey stick is part of it, and there's another dwarf elliptical galaxy that's somewhere off in the field of view that's also part of the group. But the literature on this is pretty it's pretty, there's still a lot more research that we could do, but I think right now they're putting it together as a group, but there's still a lot more you have to do. So I guess it's more appropriate to say that the whale galaxy that we saw earlier and that satellite next to it, that's really the interaction we're seeing, and possibly we're seeing an interaction between the whale and the hockey stick, but there's still more research to be done there.
Well, just checking another reference only has them a few million light years apart, which totally means they're neighbors.
Okay, so
what I saw first put them at more like 10 or 15 million light years apart, and that wouldn't really be the case. But if it's closer than that, then yeah.
But they're both very irregular in terms of their shape, so
absolutely
that makes them quite interesting to look at. So I think soon we're gonna have our final exposure of this, and it should give us a real clear view of that tidal stream to the right. But in this galaxy, it's actually colored blue. So this has a younger population of stars. So in general, when we look at a galaxy, the more orange, the core tends to be more orange because it tends to contain older stars, while the outer spirals tend to be more colored blue because they contain the younger population of stars. and this particular galaxy is just blue. So we can use that to deduct that the stars in this galaxy are probably on the younger side. And we can also see these four little clusters here, and those are probably a concentration of star clusters here.
Absolutely. Yeah, and in fact, the whale is pretty blue as well.
But in the middle, it's a little more strongly orange colored.
Yeah, but on the whole, I would say that there's a lot of blue in the whale there.
Yeah, it's pretty similar in terms of having a strong younger population of stars.
Yeah, see, when you get big bunches of star formation to take place, basically all kinds of stars are made, and those would be little dinky red ones, and really luminous blue stars. And it's the blue stars that shine the most intently. And even though you make stars of all colors at the same time, it's the blue ones you see.
Oh, whoops.
And the blue ones also don't live very long comparatively. And so as a galaxy ages, that color gets less and less blue because the blue stars die. And you tend to see more of the more orange, as you started to describe earlier.
Yeah. Okay, I think the telescope jumped the gun and wanted to move on to the next target, so I had to quickly.
Okay.
But yeah, we can clearly see the fainter bits of this galaxy, and we can more clearly define the detail within this galaxy of those younger stars and the dust lanes. So I think we can move on from this target.
So are we off to 4565?
Yes, we are.
Oh, wait, no. I mean, yeah, okay.
It is. At least
Well,
yeah, we're getting closer to the meridian. This is nearly at the zenith, so this is kind of the best time for us to actually do this galaxy. But all right, let's.
it's a shame we have to look at this galaxy because it's just really not a very nice one. It's actually like the most awesome galaxy. It's really a great one.
4565.
Yeah.
Yeah, we call this one's called the Needle Galaxy. So, and it is quite pretty. In terms of look, it's pretty good. It's a
beautiful edge-on spiral galaxy.
You'll see in a moment. Oh, all right. We're getting talk about astrophotography. So. Oh, did you read that, Scott? What he said above?
I see that Jerry was commenting on and I use this little tiny EV scope. It's a 4.5-inch telescope.
Yeah, it's the very automated one. Like
yeah, it's so super easy.
Automated out of the package.
Yeah.
See?
Run it with my phone, and it's.
It's in the corner. Come on. This tells. Okay, we're gonna have to. Well, that's weird.
Oh yeah.
We get to frame it with its little partner here, so.
Right.
I guess we'll just have to make do with whatever this. You need a minimum of a C11 to get a 19th mag. Can Scott comment on the forces that created the hockey stick?
Sure, I can do that.
I mean, I would say that it's based on what we've seen with the group, it would be some form of gravitational interaction.
Yeah, I don't think you're going to get a galaxy that's going to look like that unless there has been a close encounter with another galaxy to gravitationally distort it. What we do know is that we tend to get a lot of interesting shapes from colliding galaxies, from galaxies that make near misses past each other. In the case of the hockey stick, I don't see anything immediately obvious, like right next to it, but I think the Whale and the satellite galaxy of the Whale as well are near enough to it that they have been interacting on each other, and that's what's basically those galaxies have distorted each other.
Okay, so Kevin's
So
the dark
as we
is.
look at the Needle Galaxy here, NGC 4565, that is another dust lane
Yeah, it's
that
a
we
pretty
see.
pretty strong dust lane, very detailed. So
Yeah, it's got a really well-defined disk. It's got a well-defined dust lane that cuts across it. A pretty definite bulge of older stars at the center. A really bright center to the nucleus of the galaxy there. It's really nice. It's just a good spiral galaxy that we see from almost exactly edge on.
yeah, you can see the core is right next to that, it's right next to that very prominent dust lane, and this is also because of the. Yeah, so I was going to talk about that. So the reason why it's looking green is because we're taking this in a software and we're using we're putting the channels together, but these color camera tends to be extremely green biased. So and we don't have the ability to do color balancing right now, but and if you took an astro photo of this, you would see a very strong correlation of blue and orange. So similar to what we were talking about earlier, where the core is very orange because you've got the older stars near the core, while as you go out to the edges of the galaxy, you see that more distinct blue coloration.
Yeah, green things in space are really rare, and this is not one of them.
Yeah. Actually, when we were planning the targets, there's actually one green object that's up in the sky right now, and it comes from a very unusual interaction. But unfortunately, that was a little bit too small for this telescope, even smaller than the image scale of this telescope. And it was called, it's called Hanny's Whirlwarp. And
yeah.
And that is caused by, the term is quasar ionization echo. So I guess if you want to explain what that is.
I'm not sure I can do it justice, but basically in the sky, let me just sort of talk about greenness. You don't see green stars. The sun actually puts out more light in green than it does at any other color in the spectrum, but it's also putting out blue and yellow and red, and all of those colors mix to give us white light. And so you don't see green stars, so you generally don't see green galaxies, since galaxies are made up of stars, primarily. We do see some green in planetary nebulae. That's caused by something different, but it's ionized gas. And a really green nebula would be like the Cat's Eye Nebula.
Yeah.
That's very green. Go ahead.
That green coloration is due to oxygen.
Right. Ionized oxygen.
Yeah.
Doubly ionized, I think.
Yeah.
So to see anything else that's green is usually quite rare. That's not a planetary nebula. And this object that was just mentioned a little while ago is, I think, being caused by energy from a quasar, which again is a supermassive black hole that has a lot of things falling into it. And the jets of gas that we saw earlier, like from M87, can ionize things too, and cause them to glow much more like a planetary nebula would. To be honest, I've not read up a whole lot on that particular object.
Oh, in this case, it's because the gas from that jet is mostly singly ionized oxygen, but it's been redshifted into being green. So that's from my understanding, colored green.
Okay, so it's because it's at cosmological distances.
Yeah.
Nice. We have a combination of things
Yeah.
happening with that to get a green color produced.
Hopefully, if we get a longer focal length telescope and less annoying wind, we could introduce that. But all right, I think we've got our final image of the needle here. You can see it's less green bias now, but still pretty hard to see the color. But hopefully you can make out the blue coloration in the outer edges, and we've got this orange coloration. So yeah, I think we can move on to our next target now. And yeah, it's redshifted because it is moving away. Yes, that's correct about the quasar ionization echo, but it is due to it's due to this distance away from us.
Yeah, it's expansion in the universe causing that light to be redshifted. And back to the hockey stick, I don't know for certain, but I think it's not a head-on collision, but more like glancing blow between the hockey stick and probably the whale and or its companion galaxy that's there. I don't think we've got necessarily a complete enough picture to know the full story on that. And it's true for circling back to this whole redshift thing, you typically don't see things looking redder unless you're looking into the deep universe. But it's like in any of the galaxies that we would see, we're not seeing any red, even if we were nice and color balanced here, from expansion of the universe. But it's a thing that you could measure if you took detailed spectra and you saw known spectral lines, like the lines of hydrogen, would be shifted some amount towards the red end for a galaxy moving away from us. It's only when things get very, very, very far that they actually start to look like red because of expansion of the universe. So are we to M94?
Yeah, I'm just getting the guiding on.
Okay. M94 is another cool galaxy, and it's weird. Weird good.
We should be getting our 10-second exposure now, so we can see a little bit, and then we'll follow that up with 1 minute. Okay, all right, we can see well, it's a very interesting object because we've got, it's a very interesting structure. So we've got the core with this dust lanes, and then outside of it we kind of see like it kind of looks like a halo. So I'll let you explain that.
I'm not sure how much I can explain, nor do I know that I can turn down my reverb. But there is this, really bright core, and then surrounding that is what looks like spiral structure, but there's a fainter spiral structure too. It's like nested things, which seems really odd. I'm not really familiar.
It kind of looks like a ring galaxy, except it's actually this is actually a type of a spiral galaxy, and the reason why it has the reason for why it has such a structure is kind of still something that's being worked on, but I think you can kind of see that ring starting to come up. It's pretty faint for just a 1 minute exposure, but we'll be able to, hopefully we can get some more of it in the 4 minute, but you can
definitely
start to see the detail within the core. So this is actually a spiral galaxy, but with a much more unusual structure.
And there's even, you see there's like so there's like the bright part in the middle.
Yeah.
And then the more obviously in this image green spiral spot area, and then it's kind of dark around it, and then there's a haze out around that. And it's really kind of astonishing that there are these different sections to this galaxy.
Like, there's a lot of, there's possibility it could have been due to interaction with a satellite galaxy, or something that happened during its evolution. But there's also more examples of these spiral galaxies having a outer disk structure across the sky.
Yeah. I don't know. In my mind, it's kind of unique. I don't know of another galaxy that looks like this. I mean, they're all unique in some sense, but this seems to have these definite, discrete sections. Like, here's the outer halo part. Here's sort of the gap between them. There's this nice spiral structure, then the really bright core.
Well, the thing that would be remind of is the ring galaxy. So we see the type of ring galaxy, which are a very rare form of galaxies. So this one isn't really one of them, but this includes things like Hoag's object, which is a type of ring galaxy. But this isn't quite that. But
no, Hoag's object. Well, never mind. I was going to make a Star Trek reference. Reminds me of looking down at the Doomsday Machine in classic original series Star Trek. But this does have some elements that's kind of like that. And it probably, you're right, is the result of some sort of collision in the past. Whereas sometimes these collisions give us weird, distorted shapes like we've seen a little bit earlier. This one has perhaps come out of that, or it was been long enough ago that it has since developed very nice spiral structure since. I don't know.
Yeah. Okay, we should be getting our longer exposure, and hopefully that can reveal that bigger outer structure. Yeah. Yeah.
So in what I have here in front of me, it says that this could have formed from accretion of a satellite galaxy or gravitational interaction with a nearby system. However, further research has found problems with each of these scenarios.
Yeah. And also, apparently there's not a lot of dark matter in this galaxy. So that's also something that's quite unusual in terms when we look at its rotation curves, which is tracking how the rotation of it's one of the ways we figure out about concentrations of dark matter in galaxies. And that's how we kind of identified that there's this gravitational anomaly that could be explained by mass that we can't really observe, but is still has gravitational effects.
Yeah.
Okay. Telescope tried to do a jump, but okay.
And I agree with the comment from Fred here in the chat that this would be a great galaxy to see from the side.
Yeah.
This would be one that if we could just grab it and like move it in 3 dimensions, that would really help us to understand what's happening here.
Yeah.
But we can't. This is the angle we have.
Okay. Okay, that's pretty faint. All right, so we can see that ring structure, and we got this very bright core, and then we suddenly got this plane, and then as we zoom out, we see that big giant ring structure around it.
Yeah.
We have featuring a dust mote on the right, but yeah.
Yeah, but then there's that gap and that that other fainter structure out around the gap too, and not that. That's out of focus dust.
All right, I think we can move on to the next object. Yeah. All right. This one's. So this one's quite interesting. So let me get the telescope on it now.
Is that 4490?
4889.
Oh, okay. Oh, yeah.
Hmm. Hopefully, this one's the. So this is called the Coma Cluster, and you'll quickly see why it's a cluster, but it's not one of the stars. So
It's not what?
it's a cluster, but it's not a star cluster.
Yeah, it's a cluster of galaxies.
Yeah, it's got quite a few of them in it, and a lot of them are elliptical, but there's all sorts of types of galaxies in here. And we're just
Yeah, it's really quite awesome.
a small section of it. We're not going to see quite all of it. And we're guiding, so we're away. We'll get our 10-second exposure, and they'll help us. Hopefully, they'll let us start seeing some galaxies. Okay, we've got a. So, yeah. So if you see a lot of these fuzzy little objects all across the.
There we go.
Those are all galaxies. So
So we have we have one really obvious star or two. I think two in the image. But basically, virtually everything you see right now is a distant galaxy.
You can tell because the stars are all very pinpoint, little sharp, Milky Way stars, and this one has the diffraction spikes. But everything else is all these little tiny fuzzes. Those are all galaxies, and hopefully, our 60-second exposure will be able to see those a little bit better.
Yeah.
Give us a minute to contemplate. Okay.
I think we're trying to make up for the fact that we got off to a rocky start. Going a little bit fast here.
We have all the galaxies. We missed a few galaxies, so here's just a few.
Here's a lot.
I guess here's plenty of galaxies to make up for all of the missing ones.
Yeah, I mean there are dozens and dozens right here in this shot of galaxies that are all part of the Coma Cluster.
Yeah.
Coma because it's in the constellation of Coma Berenices, Bernice's hair. Kind of an odd constellation. But again, this is where we're looking out of the plane of the Milky Way. We can see into the deeper universe. M87 was in what's called the Virgo cluster, which is about 60 million light years away. Now we're looking more like 300 million light years away. And some of the galaxies in the cluster here, like the really obvious ones are some of I think those are ellipticals.
Yeah, most of these are going to be ellipticals, but some of them.
Yeah.
We've got some spirals, and we've got a ton, but the NGC 489, which is the one that we slid to, is
what? Is that one right there? Yeah, it sure is.
Yeah. So if we look at if we see this one is the one that we slid to. This one is one of the two main ellipticals we're seeing. So we've got so this one is classified as a supergiant elliptical because it's got quite a lot of mass, and you can see that we've got a lot of these other galaxies. So let me see if I can see that.
So this cluster is it's hard to tell here because the brightness doesn't necessarily correlate necessarily to distance, but what we're seeing are galaxies that are between like 250 and 400 million light years away. The big bright ones, I think, are both around 300 million light years. So there's a lot here to take in, and assuming that these galaxies were like the Milky Way, and there's not necessarily any reason to do that. The Milky Way has a few hundred billion stars, like 1 to 400 billion stars. And if we just assume that each of these galaxies has about the same number, some of them are going to have more, some of them are definitely going to have less. In this image that we see right now, there are a few stars in the foreground from the Milky Way. Like there's a nice triangle there near the big galaxy. Virtually everything else in this image is a galaxy. So how many stars would be in this image? Well, I don't have an answer. It's a lot.
Yeah.
How many potentially
Okay.
civilizations would be there, perhaps looking back towards the Milky Way? Well, we don't know. Maybe zero, maybe lots.
So we've got the 4-minute now, and we can see them a lot.
Oh, good.
So we've got yeah, we're back to our two main supergiant ellipticals. You can kind of make out some spirals, but we've mostly got ellipticals. Let's go over here. So I believe this one's also a spiral. But yeah, we've got a lot more galaxies than we've got stars around. So let's see, I think there's one down here. Yeah, we've got this. I think this is one lone spiral over there. So yeah, we've got quite a lot of ellipticals strewn all across the field.
There's probably a spiral there near the lower left. Well,
Also
where
the
you
top
just
right.
were, but there's one like middle left.
Yeah.
Looks like a spiral.
Top right has one over here.
Oh yeah, that's a spiral galaxy there too. I mean, but there are. I mean, I don't know. For me personally, when I look at a galaxy, it's and you actually think about what just a single galaxy is, and the amount of stars and things that are in there. And when you look at a galaxy cluster like this, it's really quite staggering to know how much we're taking in right now.
Yeah.
A lot of stars, a lot of galaxies, that's for sure. And yeah, something I tell my students all the time: space is big. I think I spend my entire semester trying to convince them, some of them, of that.
Yeah. Okay, I think we can go to our final object now. We'll have to skip M102, but go to M51 now.
Okay.
Apparently this program calls the question mark, but it's more famously known as the Whirlpool Galaxy.
It sure is.
Okay.
I think Fred's calling me an old guy. No, he's talking about the galaxies, I hope. Yeah, the Whirlpool's a good one to end on.
Yeah.
It's just an awesome galaxy.
Once we get there. Okay. Hopefully it figures out the.
In every way.
Okay, I think. Okay, let's start guiding. So we.
Messier
Takes
51. Let's see if we got it. There we do.
And guiding. Okay, all right. Let's start with. Okay, I know. All right, let's get a 10-second exposure on that. Yeah, we can already see it over here, but hopefully we can start to see it more clearly now. This is an interacting galaxy, and there it is. Obviously very green biased right now, but hopefully we can start to reveal more detail. So what you can see here on the right is the spiral galaxy, and we can see its core, we can see its spiral arms, and we can start to see its dust lanes. And on the left we have this other companion galaxy and they're interacting. So we've got them both next to each other, and what happens as a result, we see a lot of tidal streams, and we actually have this spiral arm connecting both of them. And this is a very photogenic object. It's very popular among amateurs.
For good reason.
Yeah.
It's just a great galaxy. It was the very first one ever to be where the spiral structure was identified visually with the 72-inch telescope. Yeah, kind of an awesome situation there. I've seen it visually through a 60-inch telescope just once on a moonlit night, and it was stunning to put it mildly. But the Whirlpool is just a really great galaxy, and there we go. We get the nice view there of not just the companion galaxy on the left, but if you zoom back in again, you can see there's a lot of a fuzziness off the extension of that companion galaxy.
Yeah, if I zoom out, it's pretty faint.
Oh, but it's definitely there.
Yeah, well, hopefully the 4-minute will get it. Yes.
Oh, sure. Yeah.
But
yeah, we've just got a nicely defined core on the main Whirlpool there. Beautiful spiral arms with obvious star clusters in there and dust in there, and dust along the spiral arm that connects out to the companion galaxy as well, which also has this nice, really well-defined core to it. It's an awesome galaxy. Nicely, basically face on to us, so we don't see it at some funky angle or something like that. I'm starting to lose my voice.
It's been a long night. Yeah, we're starting to see some of the hydrogen alpha. It's pretty. They're colored red, and you can faintly see their red color, but we should be able to get more of that out once we get the longer exposure. And if we zoom out a bit, there's a lot more of the tidal streams that are much fainter, but hopefully we'll start to be able to see them that wrap around all around this region. So right now we can see this little part of the tidal stream, but we should be able to get more of it out. And there's actually quite a lot of other galaxies in this field of view. So if I zoom out, okay, we probably not yet. We still need to get it. So I'll just zoom back in here. But yeah, this is a pretty. It's what you think of it's what you really think of as a spiral galaxy, except we have this interaction going on.
Right, and it's entirely possible that these spiral arms are so awesome because of the interaction that's going on there. Here I am, speechless. That's bad when I'm supposed to be giving a narration here, but it's a good galaxy. It's one of the closer galaxies that we've seen. I see different estimates on its distance, probably in the low 20s in terms of million light years. I think Wikipedia says 23 million light years. But I've got other sources that actually say 28, but yeah, so not amazingly far away. If you've got a telescope, it's not an incredibly hard object to find either, depending on the telescope you have and how dark it is. It's not hugely far from the tail of the bear, the tail of the Big Dipper, the handle of the Big Dipper, that part of the sky. So if you've got a nice view in the north,
triangle with two of the stars of the Big Dipper along, and M101 is on the Messier 101. The Pinwheel Galaxy is on the opposite side of that.
Yeah, that's right.
Oh, we just got our 4-minute. Let me zoom out. Okay, we can start to really see more of that, of the tidal stream. So we got one hanging off of here, another stream here, and then we can start to really see that gas and dust over here. So
yeah, on that side, but also around the companion as well.
Yeah. So yeah, we're really starting to see so just like a lot of these galaxies, we see the dust lanes. We can see we can start to release the hydrogen alpha regions where the nebulae are, and also some of the places where star clusters are. So, and off in this little corner, we also have all across the field. We have these little tiny minor galaxies, and when you take a really long exposure, those really start to make a lot of those out in the background. So when you image in the sky, you're usually not alone. Your target's usually not alone.
Well, there's one right now that's in the lower right. I'm sorry, lower left.
Yeah.
That's a galaxy that's in the same field of view, but well behind this group, I believe.
Yeah. One right here to the left of the companion, we can see a little, very much, it's a little fainter, but we got one at the top here, so
yeah,
this galaxy isn't alone.
Yeah, but those are in the same direction, but nowhere near each other.
These are all galaxies. These are all in the background.
Right. So when you look at the spiral structure here, it kind of looks like there's more material on the spiral arms than there is in between them. That's not necessarily the case. So it's at the spiral arms where new stars are being made, and that's where there's this preponderance of blue stars that are the ones that are the most luminous. And there are stars in between the spiral arms too, but they're not those tremendously luminous stars that shine so brightly. You can think of the galaxy as being a disk, but there's this, along this spiral pattern, that is where star formation is most actively happening. That's where you see these knots and clumps of star clusters, and that's where you see these knots and clumps of gas and dust as well. But in between, there are stars too. There's just not a lot of star formation going on in between. And back to that whole spiral density thing that I was kind of like not talking about very well before. There is thought that perhaps it is like a density wave that moves through the galaxy that triggers star formation to happen, and it sort of collides with the gas clouds and does this. But we really don't have a complete understanding of what gives us our nice spiral structure and how that is related necessarily even to the rotation of the galaxy itself.
Yeah. Like a lot of things, there's still a lot of research that needs to be done to give us the answers.
Absolutely.
Yeah.
That's why we need bright young students like you to go off and study and come up with awesome things. No pressure.
Yeah, I'll see that.
Sorry.
Okay, so we're starting to get a little bit later, so I think we can start to conclude. But yeah, we had quite a lot of issues in the beginning, but I think we were able to sort them out and look at some galaxies, and especially with the contribution of the Coma Cluster, quite a lot.
Yeah.
Okay.
Yeah, so we're sorry about the tech issues, but hope everybody enjoyed the show this evening, and yeah, hopefully we'll do another again sometime.
Yeah, hopefully with the issue sorted out. So, yeah, we'd like to thank everyone for being patient. And yeah, this is the 4-minute image. Yeah, we've been looking at it. So, just to give you a wider overview, here it is. But yeah, we'd like to thank everyone for coming and being patient with us. And we've been able to look at quite a few galaxies. So, and also, just to fill in for Doug, also to remind you of yeah, he told me to talk about the SQM project, so hopefully you didn't miss that we have to take our measurements this coming new moon, and also we're going to have more star parties in the future now on, because we took a 2-month break, but due to the weather, because it's quite erratic, but hopefully we'll be able to do more of these and start to look at more of the coming objects in the spring and summer. So I'd like to thank everyone for coming, and yeah, he's silent. Yeah, Doug's still watching though, so yeah, okay, all right, good night everyone.
Thanks everybody, hope you enjoyed it.